So recording is in progress. We are now working on the molar conversions worksheet. And this one combines other units in there, not just grams. All right, so this should be the first question on your worksheet. Calculate the volume of carbon dioxide. And once again, I gave you that chemical formula. I didn't subscript it. I think I did. And then when I put it into Google Docs, it unsubscripted it. So whatever. Is occupied by 5 moles. So 5 moles is the number that we're going to convert. And you see the word volume here. Remember, molar mass goes with grams and mass. What number goes with volume? Who remembers? Who remembers what goes with volume?
6.02 times 10 to the...
That's molecules, atoms, and ions. Which one goes? What number goes with volume in liters?
22.4.
22.4 is correct. Bingo. 22.4 liters is equal to 1 mole. So this should actually be a little easier because you don't have to calculate the molar mass on these. I threw you off by putting the periodic table up there, even though you don't need it. All right. So we know
that's not nice.
What?
That's not nice.
I'm not a nice person.
You're lying.
We've had this conversation before.
You're the nicest person on earth.
Yeah. All right.
Everybody's
so
not nice.
We have the conversion factor of 22.4. We're trying to convert 5 moles. What am I going to do? Am I going to put the 22.4 over 1, or am I going to put the 5 moles over 1? Which am I going to put over 1?
The 5 moles over
22.4.
5 moles.
Oh.
The conversion factor is never, ever, ever in that first line. Okay? So whenever you have something equal to something else, that will never be in the first line. All right? It's the number that's in the question itself that goes over 1. All right, so we have moles on top. What am I going to do on the bottom of the next one?
Put 22.4 liters over 1 mole.
Okay, raise your hand if you think we're putting in 22.4. Raise your hand if you think we're putting in 1 mole. I didn't see anybody raise their hands. It is 1 mole. I had people say 2 different things. It's actually 1 mole because moles are on top. And you put moles on the bottom. Whatever unit's on top needs to be put on the bottom. 1 goes with moles. All right, so now we look at that conversion factor. What number is going to go on top to get us to liters?
22.4.
22. Now we use that 22.4. The moles can cancel. So it's going to be 5. It's on top this time, so we're going to multiply or divide?
Multiply.
We're going to multiply, so we're going to do 5 times 22.4. What did that come out to be?
112.
That sounds good. That sounds like it's probably right. So now here I am switching up the units on you and trying to figure out if you can tell when to use what. Which comes really, really important in this next week. Giving you a heads up on that. All right, so this is the part B of that question. Calculate the volume. We're looking at volume again. What number goes with volume?
22.4.
22.4 again. I have that question written right. Yeah, okay. All right. Of carbon dioxide occupies 0.5 moles. So am I going to put 22.4 on the top, or am I going to put 0.5 on the top? Which one goes over 1? What?
0.5.
0.5 is correct because that's the number in the question itself. I have moles on top. What am I going to put on the bottom of the next one?
Moles.
Moles. What number goes with moles in our conversion factor?
1.
So what am I going to put on the top there?
22.4.
So the moles are going to cancel. So am I going to multiply those two, or am I going to divide them?
Multiply.
Multiply is correct. So 0.5 times 22.4. What did you get? Is that what you got? 11.2?
Yeah.
Yeah? We good? All right, this is liters again. Somebody mentioned 6.02. Remember 6.02 goes with the atoms, ions, molecules, and formula units. The 22.4 always goes with liters and volume. Calculate the number of moles in ammonia gas, NH3, with the volume of 80 liters. As soon as you see the liters or the word volume, what number are we going to use?
Is it going to be 22.4?
22.4 again. 22.4 liters is equal to 1 mole. All right, so we have 80 liters. What am I going to do with 80 liters?
Put it over 1.
Put it over 1. Is that 22.4 ever going to go over 1 on the very first line?
No.
No, because that's conversion factor. I have liters on top. What do I put on the bottom of the next one?
Liters. So we're going to divide.
And we're going to divide. What number am I going to put with the liters?
2.4.
22.4. And then what will go on top here?
1
1 what?
mole.
Don't get lazy with those units. I've had to yell at people. All right. I know I can't physically be there to smack you around, but pretend like I am. All right, so I'm going to do 80 divided by 22.4. What is that going to come out to be?
3.57.
There you go. Too easy? Yeah? All right, let me see if I have one in here with molecules, just so you have an example of that before we get out of this. Okay, this is back to mass. What do we use for mass? What did we do on that previous worksheet? Whenever you see mass or grams, what do you need to figure out?
6.02.
Molar mass?
You figure out the molar mass using the periodic
Jacob,
table.
you are extremely quiet.
Who's extremely quiet?
Jacob Daniels.
Oh, well, yeah. Didn't you say he had a bad mic or something?
Yeah, I know.
I have an excellent mic. Shut up.
Now I can hear you. Do you want to fight? I can go to your house.
Dr. Tamery, break this fight up.
Okay, let me just physically separate you. Oh, wait, the government already has. All right, I don't have an example in here for the molecules. Do you guys need one? Do I need to think one up real fast? Or no?
On our packet, number 11 says how many carbon molecules are in a standard atom.
Okay, let me see if I can add another screen in here. Okay, so what does it say? How many what?
How many carbon molecules are in a standard Advil tablet that contains 0.200 g of ibuprofen,
Okay, wait, 0. What?
200 g
Okay, grams of
Uh,
ibuprofen.
of ibuprofen? Then in parentheses, it's C13, H18, and O2.
Okay.
Not
So we're
N.
looking N.
No N.
Like that?
Yeah.
Okay. All right. So, with this one, it's saying how many molecules are in this, right? This is actually a two-stepper. Okay. We have grams and we have molecules. We'll need two different conversion factors for this. So what's the conversion factor for molecules? think Jacob said this one earlier.
Is
Is
it
it 6.02
6
times 10?
Yep.
To the 23rd.
Yep. Molecules is equal to 1 mole. Okay. So we're going to need that one. You also see grams in here. Whenever you don't see moles, you need to have 2 conversion factors. If you see moles, you're going to have 1 conversion factor. That's kind of like a standard thing with us. All right, so if I see grams, what do I have to figure out?
The molar mass.
The molar mass. What number am I working on? 11, you said? Is this number 11?
Yeah.
All right, I want to put number 11 up there just so I know. All right, so this is carbon, hydrogen, and oxygen. Carbon is 13. Hydrogen is 18. Oxygen is 2. That's how many I have of each. Now I need to go to the periodic table. What's the mass of carbon?
12.01.
What's the mass of hydrogen?
1.01.
And what's the mass of oxygen?
16.0.
Okay, so we had to multiply that all out. Somebody do the multiplication of 13 times 12.
One.
156 or something like that?
Yeah.
0.13.
Mm-hmm.
Okay, now we're going to add all this up. $156.13 plus 18.18 plus 32. Like 206 something. Is that right? Waiting for a number.
$206.31.
Perfect. Grams is equal to 1 mole. All right, we have 2 conversion factors we have to worry about. What goes over 1? What's the number actually in the question itself?
0.200 grams.
So 0.200 grams. That's our starting point because that's the number in the question itself. What's on the bottom of the next one? We have grams on top.
206.
206, that's right. 206.31 grams goes on top. Or on bottom, I'm sorry. Ooh, on bottom. 1 mole goes on top. The grams cancel. I have moles on top now. Is that what I'm looking for?
No, molecules.
I'm looking for molecules. I'm not looking for moles. So that means I need another fraction. That's how I know I need another fraction. Because what I'm looking for will be on the top of the last line. All right, so we have moles on top. What am I going to put on the bottom of the next one?
Moles.
Mole. What number goes with moles?
1. And then do
So
we
what'll be
put
on top?
6.02 times 1023?
Yep.
Okay.
All right. So now we have it where we want it. So we go 0.2 divided by 206.31 times 6.02 times 10 to the 23rd. Now remember, when we put 6.02, we need to use that EE button. I got 5.84 times 10 to the 20th when I put all that in. Anybody else get that? Or did I make a mistake? Are we good with that? No one's talking to me.
Yeah, that's fine.
Did somebody just meow? All right, I'm going to stop this recording now because I think we've given out enough examples.